Hello friends, today we'll study how to create linked list by using a function. Linked list creation, by using a create function. Actually, I have already discussed how to create a linked list in one of my video, but that was not using a function, right? So we'll see it today, how to create a linked list by using a function. So let's start our program. So here is our hash include stdio.h hash include conio.h. This program is a C program. Then the structure which will require to create nodes in the linked list is like this: struct node. The node has two parts, as we all know. So here is the typical node of the linked list. The node will have two parts. This will be a data part, and this is the part in which you will store address of the next node in the linked list, right? So this is a pointer, in fact, which points to the next node in the linked list. This is the next node in the linked list, right? And if the address of this node is 1000 and if address of this node is 2000, what we typically store here is this address, that is the address of the node. So in order to create such node, we'll need this kind of structure. So two parts, as I said, int data for simplicity. The first part is data part. You can store as complex data as you want here, right? But for simplicity, you are storing an integer value here. Sorry. Then the next pointer, which will point to the structure node type data again. So to the type of the pointer is structure node type pointer. Let's call it as next pointer because it's going to point to the next node in the linked list. So that's a structure which we'll be needing. Now let's go to main. So our main function, void main, right? So what we'll be doing is we'll be creating a linked list, and we'll be pointing that linked list by a pointer in main. Let's name that pointer as first pointer, and the type of that pointer will be structure node type pointer. So struct node, let me call it as first pointer because it will be pointing to the first node of the linked list. Then int n, that is the number of nodes in the linked list, right? Then I'll ask the user printf how many nodes in the linked list. That question we ask. User will enter some value. That value will store in n. Now I'll call a create function and ask the create function to create the linked list containing n nodes for me and tell me or return me the address of the first node of that linked list created, and I'll store that address in the first pointer. So here is what I'll do. First is equal to create n. So what I'm doing is I'm asking this create function to create a linked list containing n nodes and return me the address of the first node of that linked list, and I'll point that address, I store that address in the first pointer which I have already declared here. So that's it in main function. So now what create function will do? So as I just now said, create function will create the linked list which will look like this. So here is the example which create will do. if this is the linked list created by create, so create is going to return this node's address which is there in edge. So that address will be returned to us by create, and we'll store that address in first, or we'll point first pointer to the first node of the linked list created. So how I'm going to do that in create? So in create I'm going to take a pointer h, right, and I'll create the first node, and by using malloc or by demanding memory dynamically, I'll create first node. That first node I'll point by a pointer h, which I'll declare in create, and read the data in the first node. For example, the data in the first node is 10, I'll read that, and as there is no node yet, there is no next node, I'll point the next pointer to null. So in fact this is the symbol of null, right? Then I'll take one pointer called as p. I'll point that pointer p to the first node, or where h is pointing to, and in fact I'll use this p to create the entire linked list which is remaining. So that I can do like this. I can demand a memory dynamically, and that memory which I demand dynamically I'll point by using by the pointer p arrow next, which is currently null. So I'll now point this pointer to the new memory or new node which I have just created. So I'll say p arrow next is equal to new node, right, or get memory for new node. So this pointer will point to the new node. Then I'll move my p to this location, right? So then I'll read the data at this node. If the data is 5, I'll read that and I'll set p next to null. Then again I'll create a new node or demand memory for new node, and I'll point that new node by using this p arrow next pointer, which is currently null. Then I'll move my p to that node, right, like this, and I'll read the data there and set the next pointer there null. Again I'll create a new node by demanding memory dynamically and point that new memory or new node by p arrow next. See, the name of this pointer is p arrow next, right? And then I'll move my p to that location and read the data there and set next pointer null. Likewise, I can continue. I can create any number of nodes. So let's write a program, or let's write a function create now. So here is create. As we have just now said, create is going to return the address of this first node, right? That means create is going to return an address of a structure node type data, right? So the return type of create will be structure node type address or structure node type pointer. So here is how create will look like. Struct node star, that's the return type of create name of the function. We are passing n from there, so let's take local n of this create. Then, as I have just now said, in create we'll be needing two pointers like this. One is h and one more is p. So let's declare those. So the type of both pointers is structure node. P. Initially I'll need one more. I'll need some variables. Let me declare those, I, or few more if I require. I'll declare them later. So initially there is no node in the linked list, so h will be pointing to null, right? So let me say h is equal to null. Initially there is no node inside the linked list, so h is set to null, or h is initialized to null. Now let's create the first node of the linked list. So I'll create the first node of the linked list by demanding memory dynamically or by using malloc. In fact, I need one more header file which I need to include here, that is called as alloc.h. include alloc.h. I'll need that header file because it contains the memory allocation functions. So Now I'll demand memory and I'll point that memory by h. So what I'll do is I'll create a memory or node and point that node by h pointer. So that's what I'll do, right? So I'll say I'll give something, I'm going to assign some memory to h, right? So that memory I'll demand by using malloc malloc function. So let me write the entire statement, then I'll explain. Struct node star, and after that I'll continue here. Malloc, in fact this is immediate after this bracket, malloc size of struct node. So what I'm doing here basically is I'm asking memory of size of this structure node size, right? So this statement executes like this from right hand side. The size of function or size of keyword computes whatever size, whatever parameter we have passed in the bracket, right? It computes the size of that parameter, right? So size of will compute the size of the structure node in terms of bytes, how many bytes that structure node requires. That will be computed by using this size of. In fact, if we compute the size of the structure, it has two parts. One is integer value, another one is a pointer. So this will need 2 bytes, and this will need 2 more bytes on a 32-bit machine. So in fact, this size of struct node will return us 4, right? So what we are demanding is malloc 4, right? So this malloc will allocate 4 bytes of memory, right? So block of 4 bytes will be reserved for you, right? For example, let's say on 1000 location. So see here, so block of 4 bytes, let's say this is 1 byte, 2, 3, 4. This block of 4 bytes, malloc, in fact this will be replaced like this, malloc of 4, it becomes malloc 4. So block of malloc reserves block of 4 bytes, right? But and it also returns us this pointer. It also, after reserving 4 bytes or the required memory, it tells us the address of the memory reserved, right? So in fact, if the initial address or starting address of this memory which is reserved for us by malloc is 1000, malloc will return us that 1000. Now when malloc returns me 1000, this is memory address, so I need to point a pointer there. So what kind of pointer I can point there? In fact, I can point any pointer there. The type of pointer written by malloc is in fact a wide pointer. That means I can point any type of pointer to that memory. But I want to treat that memory as structured node type memory. I want to treat that as a node, right? So I'll typecast that address by using this structure node. I'm typecasting that address written by malloc by using struct node star. Now this memory is a structure node type memory, so I'll be pointing a pointer which I already have with me, h, right? So that's what happened by using this statement. Malloc reserves this much memory of the size of the structure, and it returns me the address, but the address is a wide pointer. So I typecast that pointer into structure node type pointer, and then I point h pointer there, right? So now this is a node type memory, right? The first 2 bytes are called as data, and next 2 bytes are called as next, right? Okay, so now I have node with me. I'll ask the user to enter the data at the first node. So I'll ask the user printf enter data, enter data. So user will enter data, and that data has to go in this part or in here. So I'll do scanf. So the data entered will be integer value, so %d, and I need to provide address of this location. So this location is inside the structure pointed by h, so I need to provide that address, ampersand h arrow data. If you want, you can put the brackets like this. So h arrow data is this location, I'll provide address of that location by ampersand. So the value entered by user will go there. Let's say user entered 10, so 10 will be stored there. Then as there is no node in the linked list, so we'll set this pointer to null by saying h arrow next is equal to null. Okay, so far so good. So the first node is created. Now we'll create subsequent nodes inside a loop, because that will be a repetitive task. But before that, I'll take one more pointer p, which will help me create the entire linked list as we have seen p. So let me set p is equal to h. So p will point where h is pointing, right? Then let me, okay, so now for I assigns to 2, because y2, the first node is created here. Now I'll start creating second node onwards, right? That's why 2 to n, I'll say I less than equal to n I plus plus, right? So I'll create 2 to n nodes, so starting from 2 till n. Then what will I do? I'll demand memory here, right? A structure node type memory. I'll point this pointer there, right? So I'll say p arrow next is equal to, same statement I'll write, struct node. I'll demand memory and convert it into structure node type memory. In fact, you can directly tell the size, or if you know the size of the structure, you can directly tell that size, malloc 4 for example. That will work, no problem. So let me continue here now. So as we have created a new node, and that new node is being pointed by p arrow next. Now let me take p here by saying I'm continuing here. So I'll do p equal to p arrow next, right? So now p, which was pointing here, will move to the new node. Okay, so now I'll ask the user to enter the data at that node. So I'll say printf enter data. Now whatever data user enters will have to go in this part, right? In fact, this is data part, p arrow data. So I'll do scanf %d, because data will be integer or is integer. So ampersand p arrow data, right? So this field's address I'm providing, and then I'll set this to null. P arrow next is equal to null. This is assigned null, so this is symbol of null. Okay, so let's say the data this time entered by user is 4, so 4 is stored here, and thus a second node is created. Now I think we are done. So if we now I'll go up, right? From here I'll go here, and I'll increment I. So I'll check I will become 3 now. I'll check whether I'm done with the creation of linked list or not. That means I have reached n or not. If I have not reached to n, if n is greater number, for example 5, 6, so I'll continue inside this loop by creating a new node by using this statement. So p arrow next, that is this pointer, will point to a new node created by this memory. So p arrow next will not be null. This will point to this node now. Then I'll bring p from here to here by using this statement. So p is now here. Then this message will be printed, enter the data, and that data entered by user will go in this part now. Let's say data is 5, so 5 will be stored here. Then we'll set next to null, p arrow next to null, right? Again from here I'll reach here, I'll increment I will become 4 this time, and I'll check whether I have reached to n or not. If I have not reached to n, I'll continue creating as many nodes as n is, right? So here I have created a linked list. Now let me create one more node here, and p will be here, then it is 6 if this is the last node. Let's say this is the last node, right? So this is our linked list now. So this linked list is created, it is inside create function, right? I'll have to tell the main function the address of this linked list, or address of the starting node of this linked list, that is address of this node. The address of this node is inside h, so I'll have to return that h, to return h. That's it. So this h will be returned, and that h is holding 1000, and that will give on to this first. In fact, what will happen is first will also point here. So thus our linked list is created. So I hope you understood the program, and thanks for watching.